Hello everyone. Thank you so much for joining this session. This is really great to have you guys in here. Super excited to see you guys again in one of our events. This is really nice to meet you guys again. I see Daniel is also here. Matias is also here. Thank you so much, guys, for joining. There were so many questions about. Just 1 second, my YouTube is okay. There were so many questions we were receiving about the role of AI in architecture and what is going to happen in the future. So that's why we invited to create this panel, and it could be a guide for everyone who's seeking for answers and worrying about the future. So we can discuss about the futuristic ideas that we can discuss what's going to happen in the future for architecture. So today we have the privilege of hosting two distinguished experts in the field who will share their insights and experiences on how AI shapes the future of architectural design and urban planning. First of all, we have the honor of having Matias del Campo, a renowned architect, designer, and associate professor of Taubman College of Architecture and Urban Planning, University of Michigan. His prolific work in integrating AI into architectural design is well recognized, including the design of Austrian Pavilion at the 2010 Shanghai World Expo and his recent innovative robot garden at the Ford Robotics building. His extensive research and collaborations with Michigan Robotics and computer science department make him a leading voice in the field, and also he is the co-author of the Neural Architecture, which really is a great guide in AI in architecture. Joining him is Daniel Koehler, an esteemed urbanist, architect, and associate professor from architecture computation at UT Austin. His groundbreaking research, particularly his study, the Mereological City, explores the intricate relationship between architecture and its urban context. His work has been featured in prestigious venues such as the Centre Pompidou in Paris, reflecting his significant contribution to the field of AI. So today's conversation will mainly focus on the role of AI in architecture, and each one of our panelists will have a 15 to 30 minutes of presentation. They're going to showcase their ideas and methodologies. Then we will follow with some questions from me, and also we will have a Q&A session with the attendees. There is a live YouTube going on as well. People who are in the live YouTube, they will send their questions in the chat, so we're going to explore them. People who are watching right from here, feel free to write your questions in the Q&A box, and after the presentations, we will ask them from the Matias and Daniel. So thank you so much again for joining. I just wanted to also mention about our activities regarding the academy and also architecture writings and publishings that we are doing. Make sure to check our website, and also maybe you're interested to join our workshops about AI and computational design. So thanks again for joining. I just want to invite both of you guys to say hello. Then we can go with the presentation first from Matias, then from Daniel. Hi, guys.
Hello, Hamid. Hello, everybody watching. Thank you very much for the generous invitation to join you today and speak about a couple of topics concerning in architecture. How are we going to do this? Do we say hello? Hi, hello, this is Matias.
Yes,
and then,
right
hi,
now.
Hello. And then Daniel says hi, hello, and then I start the presentation. Is that what we're going to do?
Absolutely. Absolutely. Okay. Let's have a hi and chat, then we'll go to presentation in 5 minutes.
Sounds good.
Yeah, hi, Daniel.
Hi, I'm Daniel from Austin. Good morning. Yeah,
thank you. Thank you so much, guys. So you're in Austin, Matias. Where are you right now?
I'm in New York.
Okay, cool. Great. So we have many people from around the world. It's great to have this conversation going on. So feel free to start your presentation and share your screen. If you have any videos inside the presentation, make sure that you share with sound as well, so we don't have any issues playing videos.
I don't have any sound anyways, but I cannot click on the optimize for video in this screen, but that's fine. I think we can live without that too. Can you see my screen?
Yes, I can see now.
Okay, great. So I'm gonna keep my presentation rather short. I think that a debate with Daniel might be a little bit more interesting than just showing stuff. So what I wanted to do today is basically just a couple of thoughts and clarifications about recent things, ideas, concepts that a lot of people have been talking about. Like, first of all, what's the context of what we're going to talk about today? Apart from the fact that AI is basically all around us and is basically already part of every aspect of our life, it has, of course, had a very strong impact in cultural production. And I still consider architecture to be part of cultural production, apart from the technical abilities that it has, of course. So the question is, how does this novel ecology that has emerged in the last couple of years impact the architecture discipline? The other very interesting fact is that architecture will be overproportionally be impacted by automation and artificial intelligence. This is a diagram that was published by Goldman Sachs March this year. That the red stripe is architecture, and you can see that apart from office administration and legal departments, architecture will be the third largest impacted discipline regarding the impact of architecture. Now, a couple of quick clarifications of things that I've said recently, where people have been asking me again, just to clarify that. So when I say working with AI is the first 21st century design method, what do I mean by that? If you think about that, if you think about computational design methods specifically, things like polygon modeling, NURBS modeling, agent-based modeling, building information modeling, scripting, like all these methods already existed in the 20th century. The only thing we did in the last 23 years was basically refining those things better, faster, more precise, maybe. However, what we've seen in the last couple of years only became possible recently with the invention of a variety of algorithms, as well as because of the rise of computational power, and of course, the rise of the access to large data sets. So if you think about it, for example, generative adversarial networks came out around 2014-15. Papers on diffusion models started to pop up in 2018. ImageNet, like the first large-scale labeled data set of images, came out in 2009. So this means it's a rather recent development. What is the meaning of AI in a post-human design ecology? This has also produced a couple of misunderstandings. So what I mean by post-human design is not design after humans. It does also not mean design without humans. What it actually means is that instead of the top-down pyramid that we normally consider the design ecology, where the human is on top and defines everything that design consists of underneath that, is starting to erode, is starting to become something different. It's rather a plateau now, a plateau where you have different players that are impacting the design idea. This can be humans, but this can also be plants, or animals, or the economy, or let's say geology, but it also can be synthetic intelligences, right? So there's like a whole different layer of different people, different things, different subjects actually that are influencing each other in the creation of architectural design. It is, of course, also at the same time a criticism on the idea of the author, and more like in the tradition of Gilles Deleuze and Roland Barthes, who have talked about the criticism of the author in the past. And if we're already at the topic, rethinking authorship in the age of AI. This is also something that I've been asked several times about, but I think, and I've written about this also occasionally, that continuing the thought that I was just mentioning before, we might need to rethink what authorship actually means today, considering that the result of some of our design intentions are not anymore 100% human. They can be 70%, 80% generated by an artificial intelligence. or by any other sort of computational method that learns. So maybe we have to reconsider what authorship means. Authorship is a rather novel concept, came up in the 16th, 17th century. And if you think before that, architecture was much more considered a communal effort rather than a sole genius doing something. The idea of the sole genius, in my opinion, has become obsolete. And in any ways, also this idea of the sole genius of the suffering artist is sort of a 19th century remnant that we're still tossing around for some reason. And we might rather, moving forward, maybe overcome that idea. If we do not engage with AI, somebody else will do it for us. This is also something I've stated repeatedly in different lectures. What do I mean by that? It's very simple. If we as architects do not aggressively start to figure out how AI operates, what it does, how it works, how we can benefit from it in our design intentions, then somebody else will do it for us. And this is going to be construction companies, investors, developers. And what happens if this happens is that the architect or the architecture discipline gets robbed from the opportunity to shape this new emerging paradigm. And lastly, generative artificial intelligence is nothing new. I've been surprised about the explosion in the media of this obsession with generative AI as being something new. Well, it is not. It has just become more visible in the public eye. That's its segment. So if you think about it, it's even in the naming, generative adversarial networks, which came out 2014. So this is not new. Anytime or every time you take, for example, a network or an AI that is designed to analyze something, and you turn around the flow of information, it turns from analytic to generative. That's all it does. So no big news here. Just very quickly, what is AI? Yeah. This could be like a long lecture, so I'm going to leave it very shortly. It is just an umbrella term. It's an umbrella term for a lot of different things that are happening within machine learning, deep learning, genetic algorithms, and so on and so on. So there's like a whole family of different things that are subsumized under the moniker AI, but it's not one thing. It's many things. What we basically are looking at is like a variety of different machines that have interconnected layers of nodes, of neurons, that are able to recognize or generate something. So for example, in this case, if we would turn around the flow of information, instead of recognizing numbers, this neural network would, for example, produce random numbers. Yeah. All right. Next big question. Why do we need to demystify artificial intelligence in architecture? This is a very important topic for me. There is a very interesting effect currently happening. The architecture discipline is looking at an iceberg, basically. And the only things most people are seeing are just the things that are lower. They're looking out of the water level, right? ChatGPT, Midjourney, DALL-E, Stable Diffusion, and so on. But underneath there are so many other algorithms that are incredibly useful for what we try to do as architects. That go far beyond just image generation or playing around with shapes. It is fundamentally important that we understand what is happening under the surface, under the hood of AI, to make the most out of it for the architecture discipline. As you see here again, AI branches out in a whole plethora of different applications. And the incredible thing is that a lot of applications are already there for us as architects to pick up and use, because the computer science discipline is very generous. They share everything. So if you want to look for something that analyzes the energy consumption of your building based on a large data set that understands what this consumption actually entails, you can find it probably already today if you look a little bit around. So it's not that we have to develop these tools from scratch. They are there. We just need to adapt them for our own use. So how do we change the culture about AI in the discipline of architecture? I'm very thankful for opportunities like the one today, because that's exactly what we need. We need more exposure. We need more discussions. We need more exhibitions. We need more publications. We need more lectures. We need more debates. All of those things contribute to a larger understanding in the architecture discipline about the value of AI. And I'm intentionally saying the value. I don't see it as a threat. For these, I've done things like the Neural Architecture Exhibition and Symposium 2 years ago. Sorry, no, last year, we stayed at 23. And the Data Justice AI Design Group. I want to point out that understanding the value of artificial intelligence also includes being critical about the failures that it comes with and how we as a discipline can try to avoid them. But this data justice in the context of architecture and AI, how do we do data sets that are done in a fair way without exploiting people, right? So there's like many other things. And this is a quick list. And here I used actually ChatGPT, just asking it, what are the AI models we can use in architecture? And it started to spit out this long list of possible things we can do. It's that easy. Just ask an AI and we give you probably a good answer, or at least something interesting. Why is it so interesting for architecture? Because it actually oscillates between the wicked and the tame problem. You might know that basically the wicked problem describes things that originally were not measurable, like emotions, atmospheres, artistic qualities, sensibilities, and so on and so forth. This actually provides an interesting ontological, epistemological problem that comes along with this interrogation of the wicked problem. At the same time, the same technology can help us solve tame problems, you know, optimization of structures, optimization of the sustainability of the building, better integration in the environment. Yeah. So what you have to know is that artificial intelligence is an open system, meaning that everything in the world that produces numbers can be used in a machine learning process to learn from the data. This is an important thing, specifically for architecture, because in architecture, we've been dealing very long with closed systems that are exclusive, not inclusive, that are limiting, not opening. But actually, the using artificial intelligence and machine learning allows us to have into data we couldn't do before as architecture. This even, or if we could, it was very time consuming. AI can do two things really well. One is prediction. Yeah. This is a very interesting area for architectural design. Here's a quick project I did last summer for the city of Vienna, which was about predicting how Vienna would look like in 100 years from now, with 4 degrees more higher temperature, a different ecology, with aspects of, for example, climate, refugees, but also like distribution of water and so on. It was a really interesting summer project. And then on the other end of the spectrum, so if one is prediction, the other thing AI can really well is optimization. Yeah. And for that, I have here a quick example of a project we're working on in the AIA laboratory at Topman College, which is basically, it's based on a data set of 2,000 annotated apartment plans from all over the world. 2,000 is not a big data set, but big enough for us to work with, which allows us to create a tool that understands apartment plans. But more than that, it allows also for every architect in the world to use it to improve the quality of social housing. That's the goal we have. And this is one of the things I really like about artificial intelligence. It's a possibility to improve the life of millions of people if you use it right. Then one question I get all the time: why can't we work in real 3D with AI tools? Why are so many people using just pixels and images? Well, we can. It's just a matter of really working on it. This is a paper that Sandra Manning, Alexander Carlson, and myself presented in 2020 at the ACADIA conference, which proved that you can use a 3D model dataset in order to generate new variations of houses, for example. So in fact, the main problem we have here as a discipline is that we don't have enough of these 3D model datasets that are really well curated, annotated, and contain enough semantic information to give us a good result. That's the only problem we have. So we can use 3D in AI. We just have to sit down and do it. For instance, like 2 examples quickly about work that we have done using some of the methods. For example, creating data sets. Like in this case, we were designing a house for a neurologist in Austria. We had one condition: the house had to be a mid-century modern house. So we basically took images of mid-century modern houses, created the data sets, trained it to understand the main features of those mid-century modern houses, and then create a latent work, which would allow us to use some images in a process that we call, we didn't call it that. It's generally known as pixel projection, where we basically use the pixels to project them into a space. And then out of that, we created the design of the house. This was one of the more successful attempts we had, where we were able to generate the interior and exterior at the same time of the house. And then another one, also based on pixel projection. This time, we were really curious to see if we can get anything made in 3D out of a Midjourney image. And we created these sections in Midjourney, cleaned them up, clarified them so that we can do a proper pixel projection, and then fabricated a model out of it, just to prove that we can actually move from 2D images like Midjourney to a 3D model. So these are basically two different methods that I showed you here in terms of how to create something in 3D, something spatial, out of results from AI. Either you use really a 3D model data set, which was the 3D graph evolution in the network process that I showed you, or you use a more primitive method, which is pixel projection, come up with something that is spatial, three-dimensional, can really be walked around. So these are not Midjourney images or DALL-E images. This is real. This is physical. This exists. People could really go and walk around this. At the same time, in the background, just as a side note, this is a mosaic, which was made of 21,000 AI-generated images. So just to show also the sheer amount of possible creative output you can make with this. Yeah, and just quickly, I'm also the co-founder of the Neural Architecture Group, together with Immanuel Koh, Daniel Bolojan, Sandro Manninger. Please visit aiarchitects.org. You can find a series of different positions regarding AI architecture, including also Daniel Bolojan and Daniel Koehler, who's here today. Together with Sandro Manninger, I founded the ARI laboratory at the University of Michigan, which delves rather into the more complex problems concerning AI, like, for example, as I mentioned, 3D model usage or the plan data sets. And you can find a far more detailed lecture of mine at the website remeshing-AI, or if you just look for my name on YouTube, you will find a ton of lectures. Some of the thoughts that I mentioned today were already mentioned in the neural architecture. Amit mentioned it at the very beginning. And the AD machine hallucinations, which I co-edited with Beach. In end of January, beginning of February, the book Diffusions will be finally available. This is a book that only delves into the idea of diffusion models and how architects are thinking about it. It includes also an article from Daniel Koehler. Thank you very much. Highly appreciate it. And in May, there's going to be another AD about artificial intelligence in architecture, which I think further expands the discussion that we hopefully will have today, and I try to lay it out in this short lecture. So thank you very much. Highly appreciate it. Thank you. And I'm curious for your questions. Stop sharing.
Well, thank you so much, Matias. This was really brilliant. Always enjoying your work and whatever you do. Yeah, looking forward for the new books. So excited about them. Thank you so much. Okay, Daniel, are you ready?
Yeah, of course. Yeah. Yeah, thanks for the invitation. Matias, great lecture, like always. A lot of big questions. Because like you began with so many big questions, I already thought about that you're more will talk about the big questions. So I prepared more talk, which is more hands-on, on more the latest work, what I did. And on the slide, I will speak in a way what I'm thinking of that, or like respond, maybe I'll talk a bit on your questions. Let me rearrange a bit the screens. So, and I begin to share the presentation. Do you see everything full screen? Does it work?
Yes, it's low. Yes, I can see now. Yep. Great.
So, okay, so let's start. So I'm doing it more hands-on. It means in terms of composing, designing, and my experience with those models and the questions. Maybe I talk to respond to Matthias. I think that AI is, you could also see it quite analog and quite old. Think of anything which is beyond like your individual intelligence. So the collective should be really like with capital letters written. Think of something like a corporation. Think of something like a university. So basically like in AI knowledge, like this kind of learning comprehensions from large data sets, which you can see something like a book, something like a paper, or general like a academic discourse is since thousands of years, like so the structure. So we shouldn't see it so alien, but really more see it as more way to be really like to turn or like design in a way better building, better cities and so on. So I'm very much promoting or very much or why you should actually use the AI or digital tools or anything, why it's actually good to use that for design. A question which I always get, what is actually the larger value in it that you actually use digital tools or use actually anything automated? For me, I've always the analogy that I think a city or a building should be, or at best would be as a computer, because a computer can do anything at any time. So it's highly flexible, it's highly diverse, it's in itself like an ecology. And this drives my work or my ambition in a way or motivation, why I'm like on a deeper layer actually so much interested in promoting computation and AI actually in architecture. So of course, when diffusion models became accessible or usable, also that you have really design results, I'm started to be intrigued of them and to promote them. First, because you can do quicker, similar results than with previous tools, obviously, but also because they, in a way, like begin to bring in actually larger bodies of knowledge, which you before with digital tools, which mostly begin in abstraction with kind of stacking of voxels and such algorithms, which you can't in a way integrate. Or like the most obvious, when those models became accessible, you were like seeing green pops up in buildings everywhere for a simple reason, because like these data sets or images trained on images which people in a way put online or social media is in a way inherent, like is undividable from its context. So means like you have always also trees in those images, and therefore reassembled buildings are also like full of trees. So so I'm always looking in architecture as kind of like what kind of more value and different kind of forms of compositions you can find. And that was the great beginning, like where you see you get such a higher resolution in Fuda's recombining. And mostly the kind of like what was first apparent, the kind of like emergence of like green everywhere in buildings, which now when you look into now more scientifically, you look how actually a text prompt is in a way like for a clip model relates to the original data set. Then it's because the uploaded or like the images on which these models are trained are in a way architecture is not separatable from its context, which means then landscapes, trees, and any other context what you can imagine when those data sets become more complex. So I'm used to it and always in my work like for promoting a positive future. So directly, I think those models, of course, are super helpful for giving you a new kind of agency beyond actually drawing, giving you an agency beyond or becoming again like an active part in a cultural process, which I think as architects we lost a bit by focusing too much on tools of representation, focusing too much on in a way the act of designing itself and developing tools for that. So it's quite easy today. Like I'm using usually very generic prompts, and the results still like they're inseparable from something which could exist in reality, but does not exist in reality. Or not, it's not in a way like in a common form, in form of reality. And it should also question us, like as architects, like why actually what is so simple to generate does not exist in a real environment. So, and of course, you can also then how far we can project in a way proposing alternate futures, or like constructively also going into discourse. For example, what happens with obsolete car infrastructure? What happens actually with vertical farming or other kind of like forms of food production and so on? Like how you can, again, as an architect, become quite or work on quite ethical themes, because those models like branch in such a kind of rich complexity into context. So, and then larger question, what I have done in the work, how far do we speculate and project for really staying relevant with that what we produce? Or how what is the kind of intersection between like a radical speculation of a future, or like an alternative way of different materials and forms of construction, and actually enacting that kind of speculation in a real, or making it really a new reality. I see those kind of speculations always like as a question of type, but what I feel what really changed is that type now today with AI is more framing larger questions, or really like how we want to live together. And this is fundamentally different to previous notions of notation and different forms of maybe defining a type. Very classically, like a type is always like is simply the form of like how you construct only. And this has to do that architectural notation was always about the reduction of complexity. It was always the challenge how I can draw and how I describe, and less energy I need to use to describe. In a way, it helps me then later also to build more complex forms and so on and so on. We know this also as a history. But so this is like forms of types of forms of notations, parties described by Durand, that architects use in a way, or like when you draw by hand, no? When you like what we used before AI. But in AI, like it's radically different from describing a form, describing like a pattern and so on. It uses layers, it uses feature spaces. So I'm showing here like a CNN network layer representation. A very simple network. There's a ResNet network, which is simply for image, for object detection, or similarity measurements. You use this usually. And the simpler forms of these models have around 250 layers. But that means 250 of different forms of actually representation, or different forms of embedding actually those diagrams. So how this can look like one can be just simply like something like notating RGB alpha values. But this can also be, these are self-learned layers and forms of representations. So one layer can consist of, it's not reducing to a skeleton of a building, but in a way, like it's even like spreading out, like multiplying, like a simple form of representation to thousands of images in one single layer even, and their comparison. It can be also some comparison which is completely Boolean, or completely in a way looking for very distinct kind of messaging, or yeah, like scaling this up. So, but then all those kind of different representations is in a way is analog to the classical form of a diagram, and these kind of party notions which we usually use in architecture. So, but then it would be a mistake just only to extract or only read like one single kind of these kind of extraction features. But each extraction feature is in a way like chaining through this whole data set, so looking for comments, for commonalities within this data sets and represent that. So, and this is a very reverse, a very different form of describing or reducing, not reducing, comprehending in a way the value or features of a building. And this will also change forms how we, or like if we begin to use that productively, I think it will change also what kind of forms of representation we are interested in. One example, so same question like Matias gets, like why we don't have 3D models. We don't have 3D models because 3D is not so relevant as you might think of really bringing something into reality or really describing a three-dimensional space. So what you here see is just a simple mode diagrammatic test using the so-called 1-to-3 model from Stable Diffusion, where you which learns or which transforms a single input of an image into a three-dimensional, or like which can represent that image, learns to that from arbitrary like forms of sides to represent. But when you think of it, a 3D information is already embedded in the 2D image through, in a way, the transformer of another model that, in a way, learned over the coherences of millions, billions of different images, in a way, their kind of relation between different images and data and so on. So I don't think that's also a difference. We were always looking, because we had to reduce complexity, that we were locking all information into one form of representation. Like a plan, for example, we compressed all information into, or tried like to use a plan as a layer for compressing as much as information as possible. When you work with models, which, or like now the transformer models and large language models, which are using natural language processing, then those models mean that what I can do really greatly is translating one modality or one form of structure into another form of structure. So real value would not be in now again looking as much complex kind of describing or embodying knowledge in one form of representation, but in a way being able to link between different domains, between different disciplines, and interfacing those kind of bodies of knowledge. So I think there's like the kind of design intelligence embedded, and there you should take care as an architect for beginning to design in a kind of design space. Then projecting. If I can now link all complexity and I don't need, there's no expertise in drawings, it's very obvious. Very soon we will work in a very immediate form in any kind of media which we want. This is now a speculation where like you would work with a mixed reality directly, very intuitively on a model, for example. But then think further on the kind of word that, for example, you would work in AI simulation with an AI, or like what this kind of dialogue between people or architects would be, and so on. So, and maybe, okay, give me 5 minutes more and let me go a bit into representation, or like looking into larger data sets. So over the last year, what I like to do is like looking really into how buildings, in a way, like or building types, really on a global scale, in a way, are articulated, or really spanning, simulating data to buildings and looking now for the coherences or like findings between them. So of course, like you can very realistically today, any kind of vernacular or any kind of style you have access to with those generators. So what actually happens when we can, or I think access to knowledge today is very asymmetrical, means it's not related on, or like, I don't need a large institution today anymore for accessing a large body of knowledge. I don't need, for example, satellites to make, in a way, like representing or mapping the whole world. It would be like generating images, or here you see a data set or some scrolling through representation of data set, which has at the moment like around like 1 million images of like representations of building types worldwide, which you can, like with fairly less computational power today, actually produce such data sets. So what kind of insights you can, or when you can already design your own data sets, then it means, so it's not only designing the AI, but also the data and information, and then looking for new kind of insights. So if we have this access, like from anything, anywhere, I can in a way have access to this knowledge. So what it means now for projecting this for architecture, it means I can very locally, in a way, create buildings. I can in any place now build, for example, from the site itself. Like imagine like a kind of 3D printing from source materials completely locally in kind of any kind of style, or not only style, but in a way the spatial, let's say, consistence of a source. I can also, what you here see is a latent space work, where I'm now like very crude, like work through or generate for every a certain building in around 5,000 cities worldwide, and I'm sorting them by similarity. And you see like how actually continuous or different kind of continuity in space actually, and those models give us in a kind of research on types and so on. So first insight, or like what I like to try, for example, like mapping out or changing completely now the scale, also like maybe like to Matias already, is like ChatGPT is a bit the iceberg, or like the top of the iceberg. But what it gives to us, like actually as the tip of the iceberg, is in a way having access to a lot of different scripts or representations or GitHub repositories or different disciplines through that. Here, for example, mapping out the study which I did before on like mapping the similarity of types in a way worldwide, which I think already is a completely different image or representation in terms of like how you think actually localities, much more genius. I can do this, of course, also like not only from exterior, but interior. So we can begin to think or at the global scale on a very interior or like human-related space, how social media anyhow works. So here now I'm doing the same, not working with a building, but now working with a corridor in a way through the world. We see like this whole like a collection of, let's say, set of corridors through the world. And then, but I think what new is that we can do the same with objects which before we would not grasp, like for example, trees or just grown material and so on. Don't forget, this is like computationally, but means like you can sort them, rank them. It means also you have access to data which before we didn't have. You can point out crucial information. Here, like looking into footprints, again, mapping those. So, and then maybe stopping here. So a question what I want maybe discuss then, if we are like having access to such a resolution of speculation, what kind of time scale we should project as architects in a discipline or like in research for, in a way, really realizing those projections? Is it still research should be in a way locked to a status quo? Or should we like considering the scale really and speed of AI developments and much more projecting kind of research in synthetic materials and kind of like otherworldliness of that AI? Of course, it's not an either or question, but maybe like something like how I see the interest speculate. Yeah, I'm stopping here. Yeah, thank you for now.
Well, thank you so much, Daniel. Very nice lecture, very great. Looking forward. So, just YouTube. 1 second. So we have a couple of questions. So I'm going to ask them first, then I will move forward with my own. So someone says, how can architect gain machine learning skill pertaining to architecture to be able to carry out independent research in architecture? Is machine learning is a required skill for architecture? Any of you guys can go on and answer.
Yeah, I can try. Come study with us. Like, I mean, we're both teachers.
Okay.
So come study with us, yeah? Do a PhD with us or masters or whatever. Well, apart from that, maybe a more serious response would be, I can highly recommend to do a course in Python, PyTorch, one of those, yeah? And then get a GitHub account and get a Google Colab account and start searching for things that you think you can apply as an architect. And you're going to be knee-deep in research in no time. So that would be like a short answer to the question. I don't know what, Daniel, what do you think?
Great.
Yeah, similar. I think Open ChatGPT or Anthropic or any other large language model, they already fine-tune models for Python, and begin simply to use those tools. Like begin with designing prompts that very precisely articulate what you want to reach, actually, what you want to predict, optimize, and so on. And in a conversation, those models already, they will point you to certain machine learning algorithms, ask further, and you get the Python code, and then you execute that, and you have your result. That's the great thing on what we have to learn from data science and machine learning discipline is the way how actually research is shared. And this, I think architects are very much surprised how easy actually the access is to those tools. And this we need to overcome, definitely. Like, yeah.
I couldn't agree more. I mean, actually, just quickly, I need to agree with Daniel here very much because I mentioned briefly in my presentation that computer science shares everything, and unfortunately, architecture does not do that. So this holding back of plans, of elevations, of information, of data, it makes our life trying to make a better working AI model very difficult.
Right. And also there's this idea of AI generated models are being trained with the AI generated data sets. What do you think about that? Because you also mentioned that, Matias, that there was a model with 2,000 sketches. If we generate all these 2,000 sketches, let's say via AI and then use it as a data set, do you think what is the effect of this? We're going to see this in future more. And I think we're already seeing its models, its harms sometimes in the ChatGPT. I also personally experienced this a couple of times. ChatGPT doesn't have it has some bugs maybe. Whenever I enter, what is the word count of this text, it always gives me different numbers, always. So what are your thoughts on this?
Well, I mean, ChatGPT, like many other AI applications, hallucinates stuff. And this happens all the time, you know. It depends on which kind of application you're using. If it gives you a wrong word count, okay, that might not be a problem. But if my car on the highway starts to hallucinate boulders on the street, we have a problem. So so there is like this, we really, and that's why like the machine learning people are really so adamant and careful with developing those tools for cars, for example, because that's about lives. It's not about just the word count. However, you need to differentiate between, to your question, you need to differentiate between organic and synthetic data. And it's done all the time in computer science. Basically, organic data is the one that is organically harvested, so to speak, like naturally, biologically, by people and annotated by people. And then you have synthetic data, which basically is taking this existing organic data and then interpolating between the data points to get more data out of it, which is possible. You can do it. Until very recently, it was kind of a problem, but it seems that computer science is overcoming that problem increasingly in the last year. So it's not so much a problem anymore as it used to be. Also because machines are getting better and better in differentiating between organic and synthetic data. And basically, we've run also experiments with only organically 3D modeled models and totally synthetically generated variations done in Grasshopper, for example, which you can easily, yeah. And seeing if we see a lot of differences between the two results. And the results are not so different. So I think that we need to somehow start to get easy with the idea that synthetic data might also be useful for us.
Right. Daniel, you were saying something?
Yeah, to your like kind of thing, when you say like the word count, or that the ChatGPT doesn't get it right, what was actually the word count of my last paper? Do you know that? No. So when we also, I try always like to change that. We always have so high expectation on AI, but if it becomes more like human scale, human intelligence, then we should also, I mean, like,
of course,
same like being more of a person. I think it gets it right, the word count, that it says, hey, it's maybe like 3,500, 3,600 is a similar type of essay or something. I think that the way of precision or is not so much the matter. And but it's kind of like this is a question like there's always, I think we critique too much AI by always putting higher and higher expectations. But think about, I don't know, was it 5 years ago, 10 years ago? We were discussing AI or like general like computation in terms of like how complex you can stack in a way pixels or voxels. And now we talk, or we're not satisfied with full high-res resolution in completely indistinguishable from something built kind of assemblies from very quickly on a cell phone generated and so on. So like it's such a kind of development, and still like we find always a kind of same level of critique on those digital tools. The same way, like trying always like saying, hey, it's something is missing, it's missing. And instead of like really pointing out like what is actually the potential for what we can use that and so on. So this I see a lot now at the moment in academia, like a lot what I face in a criticism always, that it's always like raising in a way the barrier, or like the kind of benchmarks, what it needs actually to achieve. And like I would like actually exactly the other discussion, or the other side of the medal, like what we can actually achieve with that.
Adeline says, thank you, Daniel. You mentioned LLMs are changing the representation of architecture because they transfer from one modality into another. Please, can you elaborate a little bit more about that? Many thanks.
Look, in a classical CAD modeling like Rhino, which follows geometric paradigms from 2,000 years of Euclidean geometry, like when you draw points, between there's a line, then you span a surface that makes a volume and so on. All the information you at first you do in one platform, but you do in a way building up a larger, more complex form of like one kind of geometry. But what large language models does, which are like transformers or built on a transformer architecture, which means they can translate one kind of structure into another structure. That means like knowledge is not embedded in the kind of domain or like one kind of geometrical modeling, but in a way between different kind of forms of representation, which we now have like between text and the 3D or text and 2D. So I should much more look in how actually this transformation actually is notated, or like where is actually how I'm influencing actually that kind of translation between like or like between image and 3D, or like my intentions textual described and the 2D and so on. So you're much more looking between different platforms of software more practically. And you see also first applications of that. I think the most famous is NVIDIA Omniverse or so, like where you see actually platforms evolving, which are actually putting attention into kind of interfacing between different existing forms of geometries.
Also, there's this idea of I saw this in the questions as well. The importance of interdisciplinary developers, or in collaboration between architects, developers, because none of these tools, AI tools, they're not meant for architects as much as all the softwares are not built for architects, and we're just maybe, I don't know, maybe we're misusing, or we're somehow trying to figure out and explore and bring new things to architectures. Back then with CATIA, then Maya, Revit, AutoCAD. So what is the importance of interdisciplinary people who can connect with architects and developers, and also involve architects in more of these processes, so we can have more understanding of the tool? Because right now we are just a user. We're just end user with architects, and how we can solve this, how we can get into the technology, because number of architects who are also understanding developers, or they know these languages, or they know what are LLMs or anything like this, are very limited. And what's the best way to solve this?
I mean, I think this is really crucial. The know-how to understand how an AI model works and how you can benefit from it in the design process only can come to you via other disciplines, I think, because or you are a former computer science student turned architect, maybe. But other than that, I think you need to really look for people in computer science, in robotics, in data science. Robotics, for the reason that these people have very, very good people, for example, in machine vision, which we also can use in architecture. Yeah. So you have to like understand, I think, or maybe let me put it another way. Instead of just saying, yes, go to computer scientists, I think the first thing you have to ask yourself is, what problem do I want to solve with it, right? Like, because that's going to define who you're going to ask. Do you know something in that direction? Do you have an idea how I can solve this? Like if you want, for example, to understand the material flow on a construction site during the construction, right? That's a problem, right? You have to understand how do I want the entire infrastructure of my construction site to optimize the flow of information, data, and material on the site. That's a very specific architectural problem. So you have to, so you think about time, you think about transportation, you're thinking about material flows, you think about manpower, and so on and so on. So it's like a whole universe of problems right in there, which you might not solve with one algorithm. It might be a series of different things that have to come together to optimize that one instance. Yeah. Once you describe that, and even better, if you can describe it in a pseudocode, that would be even better. You can go to some computer scientists and tell them, look, I have here this problem about how to optimize the material for my construction site. I have a couple of sketches and ideas. What do you think? It's nothing different that we have done as architects in our entire life, right? I mean, you're not a structural engineer as an architect, but you know enough about structural engineering that you can go to one and talk to him. Yeah, that's the whole idea. You don't need to be a computer scientist, but you need to understand enough of how this whole thing works that you can go and talk to computer scientists or data scientists. Yeah. So I'm basic. I don't know if we have to get rid of something else, because there was also a question about education. This is part of it, understanding how to amass enough knowledge about how these machine learning processes work, so that you can talk to computer scientists. We're adding like another thing on our education on top of the things we have already, basically. The question is, do we drop something else for that, right? I don't know, maybe not. Yeah. Either way, long story short, yes, it is an interdisciplinary endeavor, and I think without the help from other sciences, we're gonna have a hard time cracking the code, so to speak.
Yeah.
I mean, there's to say that English is the new programming language. And I wouldn't underestimate how simple it is really with a large language model actually to construct and actually pseudocode or like construct actually your needs or like your problem, and then actually it helps you for like what kind of code base and so on to use. But this is like in a technical layer, but we can also, what means interdisciplinary in architecture, like in design itself. What I noticed now, especially with studios or like with students working, that the projects become much more richer, much more interdisciplinary. Because it's so easy, like, I mean, for when we started studios just a few years ago, you were starting a few weeks, like some really hard, tough scripting, whatever kind of workshops, no? Learning a new platform, new software, like really challenging. Today you open something like a Discord chatbot and just begin to type.
Yeah.
So instantly the questions are like, what I'm doing actually. And now when it's so instantly you can draw, your attention goes much more to like a different complexity of building. So my students now, they all want to use materials which are not usually used, which are, of course, like replacing concrete, glass, and so on. They're interested in embedding the life cycle of buildings. Now we have projects where like students, they start to think about the aging of building and so on and so on. There's a new complexity we get, actually, what we design, how design. So, and this is, I think, also a notion of interdisciplinary design, that we actually look to the context much more of a building in different times and modalities, or constructing your materials and so on and so on. And that's I think very intriguing.
There's a little problem to that, Daniel, that I would like to point out, which is doing so, yes, it makes a lot of things much easier, but at the same time, students become technically illiterate. And on the other, and the other problem is that if from one day to the next, OpenAI decides to charge $100 a month to use ChatGPT, it will exclude a lot of people from doing that. Versus if you teach them actually how to code it, there might be still a chance that they can use it. Yeah. So I know what you mean, and I agree also that it has become much easier with these sort of large language models and diffusion models and so on, at least to teach the basics of what it's actually doing. But in order really to make an impact, I think we have to change from users to tool makers. And I don't think this is my quote, by the way. I think somebody else said this surely before me. But it's really, and you, Daniel, you should be the first one to subscribe to this. You were doing this all the time for the last 10 years, I don't know, 15 years or so. Yeah. So I don't know. What do you think? Am I wrong?
No, I think that I don't think that we make tools anymore. Or we had like in architecture research, we made tools for other people to use. Now we make tools to use simply. Like it's not anymore a distribution chain, because like you can so intuitively, so quickly actually to design your own unique tools per project, that I think everyone will does tools. So and when you say like, okay, now at the moment, of course, like there's only like 1-2 larger models existent, but like the cost of training them and also open source models become much more competitive. It's only a question of time till you will have your own custom large language model as your, in a way, personal assistant, which somewhere sits on your cell phone or so.
That's already happening anyways.
Or it's already as a, we have those
it's
already.
there.
Yeah.
So we have questions from attendees. Masoud says, thank you so much for the presentation. Dr. Matias said the AI can predict and optimize. So how can machine learning help to have an optimized prediction? Is it about algorithms or something, or do we have to go more deeply through data sets?
I mean, it all starts with the data. Yeah, it's the usual old computational quote: garbage in, garbage out. If you don't have good data, you're not going to have good results. Period. Yeah. So it starts with that, and then what kind of algorithms? I have to say that I'm very hesitant to say use this or that algorithm for this or that application, because the problem is that those ideas and concepts are evolving so fast in computer science that next week we can have a great paper about somebody doing an even better. So what I can recommend is exactly that. Have your eyes open for interesting publications from computer science conferences with things that might be useful for you, that you're like, oh, yes, I can use this to optimize, I don't know, some part of my design process, yeah? Also, the funny thing is that the term optimization is actually really going through a semantic change currently, which is kind of interesting to observe. So in the 20th century, when we talked about optimization, we always had this sort of technocratic idea of just, you know, better, faster, less, and so on. But this is changing at the moment, because if you think about it, what, for example, a diffusion model does in regards to your prompt is it's actually optimizing along the prompt to achieve a specific result. This result can be something that is completely unrealistic and completely useless, yeah, but it optimized towards a sort of aesthetical goal. And this is really interesting, because previously optimization was never considered to be towards an aesthetical goal or a visual goal or a sensibility goal. But because of the way how machine learning is starting to interrogate also the wicked problem, as I described briefly in my lecture, it can actually change the whole meaning of what optimization actually means. Because what does it mean to optimize a wicked problem? It's kind of a weird idea at the end of the day, but it's really, really useful for design purposes. Either way, I'm going somewhere else completely now if I was trying to answer here. In short, the data is it. The data is very important. We need much more really well curated, annotated data in design. Please do not pester me with unsupervised learning, because we just don't have enough data in architecture to do that. Point. Yeah.
Right.
So we're gonna see where it goes. But data is it. Data is the key.
Yeah. I also had a question which I saw in the comments as well. Ozan mentioned about it as well. As a designer, an architect, how do you feel about the relationship with AI? How much it changed you and your process? And also adding to that, since the last year that we have some creative, some tools that we are involving in our creative design process, how much of architecture have changed since last year?
I want to go first.
Yep.
Yeah, I can. Yeah, not much changed. Architecture is so slowly, also even in academics with conferences, peer reviews, which the whole process in architecture, like academically, like takes up to 1 year to actually publish a research. A building takes 5 years or so to go really on site to opening. So I think it takes, unfortunately, it will take very long till we see like real implications of that. I think it's only starts. We see glimpses about that. So, yeah.
I mean, I do agree with Daniel on this. And also, like, you have to think that we're going through a hype cycle right now, right? So everyone is talking about AI and oh my God, blah. Either it's going to kill all of us or it's going to save the world. I don't know. There's like the whole disparate ideas about it. Lots of people in architecture being afraid that they're going to lose their jobs. I don't think that's going to happen very soon. Yeah. But I can only tell you that, you know, using AI, you know, improves your arsenal of possibilities as a designer, I would say. It gives you another possibility to think about design. And I don't think that architecture, Daniel was completely right. Architecture is a very slow discipline. So I don't think it's going to change a lot in short time. The only way that it's going to change a lot would be if from one day to the other, the construction industry picks up on this and says, I want to change a lot of things because it improves my monetary gain. Yeah. And that's what it's all about. I think that it's going to change in terms of discourse, for sure. We see that already happening. Yeah. That the discourse is changing. And I also think that we're seeing an aesthetical change, which is great. Yeah, we're suddenly, I think, discovering what aesthetics in the 21st century actually mean for us. With help, with the aid of machine learning, deep learning, and a variety of other tools. Yeah, so this expansion of the human mind through the use of technological means, which was always a goal, is a goal we had as humans for a long time. I think we're closer to achieving that goal. Again, it's not replacing humans; it's expanding. It's expanding human abilities.
Mm-hmm. And so there's a question about the sustainable buildings, how it can help us towards a more ecological impact on the planet.
Oh, very simple. Speculate on different forms of construction and materials. Or look at was just recently, Alphabet, Google released the database of, I think, 3 million new synthetic materials. Begin to use that. Begin to explore exactly what data science or like anyhow the community already provides or offers as an input. And it's up to you as an architect, really, with your creativity and your agency and advocacy, really taking it on and saying, hey, that could make really sense, and realizing that, no? and then bring people on your team, and so on and so on. Yeah.
I mean, I mentioned this already briefly in my introduction, that basically working with this kind of tools, working with AI, generally speaking, it's an open system, which means all sorts of information that you can gather can go into your design intention, including ecological data, biological data, wind conditions, and like all those sort of things. I know we had systems before that did this already. Building information modeling did this. There's a bunch of grasshopper definitions that can do this kind of stuff. Yeah, but imagine to have like an enormous amount of data behind it that informs whatever result you're going to get on a far higher resolution, with a far higher probability to be successful. And not only in the planning phase, what I think is amazing is that you can basically plan ahead, predict, as I said, prediction is one of the great things AI can do, predict the whole life cycle of a building until its demolition, right? And figuring out how these materials are going to be reintroduced into the system again. So you can really do like a long-term understanding of how the ecological impact of a building will be, not just the construction fit.
Right. Go on, Daniel.
Yeah, I think there's Matias already a bit hinged on that. There's a really categorical difference that the AI models are much more ecological in thinking, because it learns from large data sets. It means also the kind of conclusions or comprehensions are inseparable from larger contexts. So when previous simulations or like a classical sun study was just about the volume and shading of adjacent buildings, so now those similar studies would also reflect the cultural context. Because generally like the shape of context, so it would use looking to different porosities, or I don't know what it would do, or would you already like choose or look for solutions which are entangled with other layers of that context, because it's inherently learned from that, or like all the totality of anything what you can look at in a certain range of images or whatever your data set is. And this is fundamentally ecological in thinking, you could say, and always there's certain criticism or like ecological thinking what always had to modernism, and especially like to digital tools, that they actually always worked in the abstract realm or always separated. So, and this now we see more and more to be able to overcome, that we can much more integrated and much more interdisciplinary begin to work and construct those or design actually then solutions, which are not solutions classically sense.
Yeah. So that also says it seems the designs that get generated through AI models are very complicated these days, more complicated than current structural engineering and materials are prepared to address. How can we keep up with the capabilities of the creative potential of AI in terms of real world execution and construction? I think more or less it was mentioned during the lectures, but if you want to expand it.
It really depends on which images you're looking at. I don't know exactly what you're looking at, but you can do AI design as simple as you want or as complex as you want. This is the beauty of the system. It's open, so it means you can interpret it in any way you want it. However, right now, and Daniel also alluded to this in his lecture, like a ton of the work is basically 2D, right? And the moment you really have to make a physical model is when the rubber hits the road, yeah, because you have to make sure that it really works, yeah. And starting with the physical model, you can start scaling it up to the building process, which of course will be done with materials that exist and that is are approved by the law, and of course also have standards and so on. So I think we're not in the phase. I mean, there's a very small amount of people right now operating or really delving into working with AI who really have done physical models. I love Daniel's animations of models in buildings somehow with people around them, like faking a gallery, basically. I think this is kind of amazing. It's so bizarre and it's also so surreal in a way. I like it. I think it's awesome. Yeah. But my images were real. Sorry. Yeah, those were in a gallery built by people, standing there, people touch it. Yeah. And we're getting there, but we're just slowly getting there. I can tell you one reason why we're getting there so slowly. When you move from 2D to 3D with any sort of neural network, the amount of calculation power necessary to process it goes up exponentially. Yeah, which means that we only can operate with low resolution models when it comes to 3D and neural networks. We're going to get there, but it's going to take a little bit of time. As I said before, next week, a genius computer science graduate can write a paper that will simplify the process tremendously for everybody. But until then, we're stuck. If you want to show something in high resolution, beautifully rendered, with a lot of detail, we're stuck with the image generators. Yeah. So, long story short, those models that you see in AI are just basically visualizations. And as people already said before, paper is very patient. Yeah. So a visualization is great, but it's something different than going out there and building it. And you know, we actually did the first, I think, build project using machine learning, which is the robot garden. Yeah. It's a simple project. It's nothing complex, right? But it was a proof of concept that we can use AI for design. Yeah. But it still took almost 2 years to build, and architecture is slow, right? So we're gonna see. I don't think we have seen yet what AI can be as an impact on the built environment, but I'm pretty sure we're gonna see it very soon.
What do you think could be the most awaited feature, or the most awaited AI could be emerged with architecture? Is it 3D modeling, or is it like real world construction bot or AI robot, or what could be the most awaited one?
No, I think the most important and the most awaited one is actually to change the mind of architects in the way how they understand the world, because that's going to change architecture.
Of course.
I think we will see a lot of changed modalities. We will now working very much in a classic frame set, how we would design and construct the building. And I would question that as well, that why it should stay that there's a designer who makes a set of constructions which gets delivered to a developer who puts something on the side. Example for that is we have now a little startup where you generate an interior based on your interior, and then you get shipped that furniture at home simply by connecting or like not doing that 3D generation or like deriving that a bit or making some little cut plans, but connecting those cut plans to a bidding marketplace where like any kind of workshop can actually produce that or put an offer on it, and then in a way ship the produced product to you at home. That's possible because it's connecting not only diffusion model but text model, this model, you have actually a chain or a set, or you design in a way your own supply chain and so on. And I think that similar, this just now a quick example, similar innovations will come to architecture, that we really in very orthogonal ways, so like very differently to the common kind of flow of construction, we actually begin to build. So for me, like when you say what would be a great tool, yeah, like translate the image directly to a path. Actually, Komatsu Koehler has in project where like they have an image recognition robot, and then it throws like a bag of clay to a certain heap and piles up then a formation of a building. So such kind of, I think that such kind of translations much more maybe the direction than looking into like a classical set of representations or then the 3D 3D. The 3D is the realized building on a side. But anything what comes before, I think is much more will relate to highly accessible and abundant data. And that's simply text and images at the moment. And I don't see any way that we will have this with 3D. Maybe our phones are very great in LiDAR and splattering very soon.
Yeah, but it will take time, yeah. Of course. Yeah. So I'm going to skip a couple of my questions, but there are some good questions in the Q&A box. Shaun says, in design pedagogy, educational strategies, what specific goals can instructors set for students using AI? How can these goals be measured in both technical proficiency and creative innovation?
Do you mind if I go first, Daniel?
Yeah, go first.
So just to give you a little bit of background, I started teaching thesis projects based on AI algorithms 2017, 2018, something like that. So I have a couple of years of experience now doing this. And one of the, like, there's like different blocks, I think, that has to be considered when it comes to the pedagogical concepts around using artificial intelligence. Like one is, I mentioned this already also in my introduction briefly, the demystification of AI. Like making people understand that AI is not this kind of voodoo magic thing that does things when you type in a couple of words, but that there's a very solid technological background here that explains to you why it does things the way it does. Or, for example, teaching students that this is always fun when I tell students, for example, that their data that they're collecting on their phones, images that they tag, addresses, even the way where they're working around, that they're sharing this all the time. The companies were providing this. And also, for example, if they download a free filter that makes like funny ears on your head or something like that, it's not for free. You're basically training an AI to get better in facial recognition.
Yeah.
So these sort of things, I think you have to give students like this whole ecology that is currently emerging around us in terms of what artificial intelligence is doing. Like why is Amazon recommending this book to you? There's a reason for that, and most of the time it's a machine learning process. Yeah, and like trying to unravel or somehow unfold what this ecology we're living in, which already is completely inundated with applications, is doing to you as an individual, and basically how you as a designer can leverage that ecology to make your designs better. Yeah, so it is a combination in my education. This is a combination between theoretical, discursive ideas, concepts, and progresses in it, like really theory, so to speak, about the other. And on the other side, practical, technical skilling. What does this thing do? Why does it do that? And again, interdisciplinarity here is very crucial. I have, for example, students like graded students from computer science coming over to our studio, assisting me and my students, and specifically my students, to debug their code, explaining to them how these things work, showing them tricks to code faster. So it's not me teaching only them that, but it's also people from science coming over, or people from robotics coming over explaining what is machine vision, and then we discuss how can we use this in architecture. Yeah, so it's really this sort of soup or ecology of different things coming together that allows students to have a better understanding of, first of all, the world they're living in, and secondly, how they can do and impact as architects in this ecology with these new tools. That's kind of what I'm trying to do.
I can only follow up. Like most important, I think at the moment is critical thinking. Like being how you can be more conscious. I'm now refraining Matthias' comments. Yeah, how you refrain, or like how you learn in which context you are, and how you now advocate or like build up your own agency. That means also in terms of how you develop now a project, it's less the traditional forms of notations, but I'm looking now how clear you communicate actually your ideas. And now it can count anything, like it's from hand models, sketches, movies, like any media you can actually use. So it's much more how more innovative, more precise actually is the kind of like chain of thoughts, or like your kind of staging of a project, how relevant it would be in a real setting, and how clear you communicate that.
Right. Yeah. And there's a question about, I don't want to take more time, maybe another 10 minutes, and we're going to close the session. So we have some questions from Adeline. Probably we discussed about it, but if you want to expand a little bit more, thank you so much to all three of you. What will happen to the sizes of architectural firms since we no longer need minions to do the labor work and CADing or rendering, etc.? And maybe architects will need to find their niche from now on, focusing on environmental designs, vernacular housing, focus on materiality, and etc. What I mean is, previously, those who designed generic facades or copy-pastable models in China and perhaps are going to quietly be replaced by clients doing the design themselves in-house. Would you agree? The margins are thin in our field. Are we optimistic that AI can help our market out?
If you look to a company like OpenAI, they have how many? 500 people?
700 probably, yeah.
700 now. But how many now? Is it already 2 billion people using that? So like more AI means also like more asymmetry in use. So much to the scale would be a first prediction. But on another side, automation means never like there will be less work, just a different kind of work. You're freeing up time for doing now in a way, yeah, a more richer in a way designed. Like like we talked about already, like you're already framing it with your question, Adeline, that you talk about, yeah, life cycle, material research, and so on. What I noticed, and what you notice in academia, that a lot of people from different fields reach actually out to architects because you're good now in actually designing 3D in a world or understand spatial complexity. And when now really computational AI like really becomes another layer on a physical world, so there will be much higher demand on people who are really expert in this kind of interlocking, or not, like where it would be relevant to have like some computer aid or some augmentation, and so on and so on. So like I think more that our work or our expertise is much more demanded now actually in our fields. We just need, again, like we need a different mindset or consciousness actually about that, like how valuable actually our knowledge can be in also our mediums as like pure the classical form of a building. Yeah.
Right.
Yeah, it's a good question. I remember I had a similar debate a while ago, and I had like two scenarios. Like, or actually, I think it's in the meantime might be more than two. But the two that I described back then was, on the one side, there's going to be large-scale companies in architecture that basically are gonna try to dominate the game of doing data sets for architecture applications, because you need money and manpower to do that. Yeah, and this can only be done with large companies. So the architect's job is going to change in these large companies, rather from, I mean, they were never really a lot about design. They were mostly about, the economy of the project with these large scale companies. So this is going to be different. And then on the other end of the spectrum, and this is the extreme, like the extreme, these large scale companies that are doing of run of the mill architecture, very fast, very quickly, very cheap, and very effective. And then the other end of the spectrum, and very automated. And the other end of the spectrum was something that, don't laugh at me because people tend to do this when I tell this story, is I think there's going to be offices that are going to be super tiny boutique offices that do not use any computational tools at all, that sell architecture as an artisanal product. Yeah, where it becomes exclusive and very valuable because it's manually handmade by humans with no intervention of any sort of computational tool. You know, you get real ink plants and base wood models, and you know,
like those handcrafted
all handcrafted. Yeah. Some students were sitting there gluing the thing together by hand, no robots, no 3D printers, nothing, just a cutter and glue. Yeah, because you know that makes it valuable. It's done by humans. Yeah. And this could be really a fun world, I think. But I think this is like two of the, it's going to be somewhere in the middle, I guess, at the end. Yeah.
I have already students who are merging that and literally making clay models for them, automating drawings out of that.
See?
Cool.
Yeah, so totally. These things are going to happen.
Right. And there's this question of Khaled who says, what exactly the problem we are trying to solve with AI in architecture, in your opinion? What are we looking for?
Yeah, I mean, I'm not sure if there is a new problem we want to solve. I think we're just trying to make architecture better somehow. And like the difference being like, I mean, you know, we have debated for the last 50 years how to make architecture more ecologically viable, culturally important, beautiful, useful, practical, like all the things are being asked from architects. I think what we're trying to do now, or at least how AI can help us in doing that, is because it's just providing the design with a higher level of information based on data. And that information hopefully will be better. The only thing we as humans might need to overcome is our selfishness in always thinking we're always right. We might not be always right. There are other intelligences now out there that can help us improve what we do as architects for the built environment. And maybe not even for the built environment, but it's for architecture in all its different meanings, which is a lot. It's more than just building, right? So, I mean, I'm not sure there's a good answer to this question. I think we're trying to figure out what we can do.
Yeah, there's always to say that architects make problems and engineers solve problems. So, and I mean, like a building.
Maybe architects are the problem. We should remove them.
No, but architecture, you can't say a building is. I mean, there's not a better. There are better or worse buildings, but there's not the best. So there's not really a problem to solve with a building. So it's about what Matthias mentioned, like the idea of life quality, of really like a good working city. And AI brings more like a new problem, which is actually that you notice it's not only about humans in cities now. It's not only about robots in cities, but like, you know, you have a leveraging of different agencies. And this is, I think, a great opportunity for making cities much more heterogeneous, much more entangled also with nature, with really increasing by this life quality, by making much more, like greater places. That's it. Like, yeah.
There's a good question in here. Albi says, hi, thank you so much for great presentations. You said that the datas are the thing that will make the process more efficient, and also that more data is the key. What is your concern about the way how we approach the design process, problem solving, and finding out what solutions will be able to produce a functional and aesthetic architecture? Can this new way of working function, but not intervene on the decision-making process?
Yeah, that's a great question. I mean, I would like to make a quick comparison to the way how military is using automation. When you have an automated drone that is loitering over a battlefield, right? You do not have a drone that on its own will decide whether to bomb or not to bomb. There's always something called the man in the loop, a person, a human, that ultimately makes the decision whether to hit the target or not. Yeah, and I think that in architecture it might be similar. We can get proposals, ideas, concepts, suggestions, images, texts from AI, but ultimately it's the human who decides whether it's the right decision or not. By the way, not every architecture is efficient, right? I mean, good architectures sometimes it's not efficient at all, right? I mean, if a room that could be like 2.80 meters is 5 meters high because an architect decided this is the right aesthetic decision, he probably was right, even if it's not a very efficient or practical solution. Yeah. So it's not all about practicality or efficiency. It's about like how do we progress into an architecture that is a comment to our current human condition and the way how we see the world. I mean, architecture is so much more than just. I always resist the idea that architecture is just buildings. It's not. It's a culture. It's a way of life. It's an idea.
It's more
than
concept. Buildings. Yeah.
It's more than buildings. It's also writing books about architecture or the world, if you want. Yeah. So this is again the question about authorship more than anything, or the creativity. So I think, for example, some people have assigned creativity to AI, which I don't think is true. What happens is that AI or this image generator, so whatever you want to call it, machine learning, it provides you with solutions or ideas or images. And it's the human that creatively interprets that image. It's like, wow, that is cool. I want to use that. Yeah. So it's sort of a protection of our own creativity to what the machine does. Because the funny thing is that AI, generally speaking, cannot come up with anything new because it's always working with data. So it's only the way we humans interpret the results, which sometimes are in a weird corner of the letter space, that tells us, yes, that's interesting. That's it. I want to. Yeah. So long story short, AI is not taking away anything from humans if we don't let it take away from us. You still can interfere. You can always be part of the process. You're still the one actually talking off the process, starting the process. Machines don't do anything on their own. It always needs humans to do it first, to start the process. Yeah. So no, it's not going to become repetitive and cold, right? So that would be a mistake you make, not the machine.
Right.
I mean, yeah. Just look on the last year with the diffusion models. I mean, there was never, I think, a phase in architecture which was more heterogeneous, more funny, more colorful, and just very exciting in terms of what you see in kind of proposals, like as design. So I wouldn't be worried that with AI models progress and become more complex, I think the opposite will happen, that actually architecture becomes much richer through them.
Great. Well, thank you so much, gentlemen. These were very great questions, and there are some of them that I don't read because they are repetitive questions, and we already mentioned some of them, but you also guys have access to the Q&A. If you want to go and answer any of them, just let me know. I can read them. So, but more or less, thank you so much for sharing your insights and valuable experience about AI and the role of AI in our profession. Yeah, looking forward to have you back in our platform, and also Matias's new books to receive and study them as soon as possible. We appreciate your time and thanks for joining. Looking forward for your work, great works that you're doing, and you're at the forefront of this technology, and you are the guys who are leading the way and also showcasing how we should behave, how we should integrate it with our profession. We're just learning so much from you guys. Thank you so much, and
thank you for the invitation.
Yeah,
thanks for having us.
Yeah,
thank you so much.
Great discussion.
Likewise, thank you. This video will be available on YouTube. I already shared the YouTube in the chat, and you can go and watch from there. If you have anything to ask, just let us know via email or anything. We're gonna make sure to send them to Matias or Daniel, or include them for the next panels to discuss more about the topics. Thank you so much, guys, and see you soon.
Thank you. Thank you, everybody. Have a nice day. Bye.
Likewise.
Nice day.
Bye. Make sure. Okay, guys, thank you so much for watching. Make sure to check our